So welcome back guys. Now in this particular session we shall be talking about the skew, right? The skew. So basically if we talk about the skew, right, if you guys remember, right, we have already talked about the normal distribution curve, right, that it is having what kind of shape? It is having a symmetrical shape, right? Skew, basically if we talk about, this is the non-normal, it is not normal, it is non-normal distribution curve, right? So basically skew, it is actually describing it, or it describes non-normal, it is not normal, right, non-normal distribution curve. So for the revision purpose guys, you know, this was the and according to that we shall be talking about the types also, right? So you know, this was the symmetrical distribution where we had to talk about in the normal distribution curve, right, in that chapter, that you know, this is the symmetrical shape, very nice symmetrical shape, and we had to talk about that on the center we will be having the mean. With that we will be having the mean, median and mode. In the symmetrical curve, in the normal distribution curve, we will be having mean, median, mode coinciding at the center, and we have talked about that majority of the population will be residing at the center only, right, and very few people will be present or towards the tail region, right? We had already talked about that. Now this center line will be actually representing the zero number over here, where the mean, median and mode, they will be coinciding. So here the mean, median and mode, they will be equal to each other, right? Now if we talk about the types, we shall be having two more types over here. One is the non-normal, one is the normal distribution, then we shall be having the non-normal distribution, that is called as skew. Now either there could be the right-sided skew, either there could be the left-sided skew. Skew depends on the tail of the distribution curve. For example, these are the tails of the distribution curve. So here we are seeing that they are just centrally aligned, you know, the distance between the distance from the center, they are just equivalent as far as these tails are concerned. But if we will be seeing particularly this one, for example, there is a negatively skewed, or this is also called as the left-sided skewed. This is also called as the left-sided, you know, left-sided skew, right? Why is it so? Because if you will be looking at the tail, you know, always you need to look at the tail, right? So if you will be looking at the tail, this tail particularly, it will be going towards the left side, and if you look at this tail, this is looking fine to me, but if you are taking this tail is actually going towards the left side. That's why this will be called as the left-sided skew or negatively skew, because it is going towards the negative side, right? And if you guys remember, we had talked about the standard deviation also, -1 +1 standard deviation, that was that was telling us about the 68% of the population residing over there. Then between -2 and +2, that was about the 95% of data, and between -3 and +3, that was about the 99% of the data. Then we did talk about the zone of normalcy also, which was representing the 95% of the data, that was showing us between the data of -2 to +2, right? We had already talked about that. We had talked about the standard deviate also, that was Z, right? We had talked about the p values also, that was 0.05, which was representing the 95% of confidence interval. Confidence interval was nothing but the, you know, difference between the standard deviation only, that -1 to +1, -2 to +2, that was showing the same data, right? We had to talk about already all of these things. We had to talk about them in detail in the normal distribution curve. In this one, I just want to sensitize you with the two more types over here, negative skew and the positive skew. However, we have to talk about in that particular section also. Now this is the positive skew, guys. Positive skew here, you know, I am seeing that in the negative skew, first of all, you are seeing that mode is in the center, you know, mode is at the top. Then if the tail will be going towards one direction, the mean will be going towards that direction, and between the mean and the mode, median will be residing. So here we can see the mode is present over here, mean will be going towards the tail now. So here the mean comes, and between the mean and mode, there would be the median, right? Here the curve was symmetrical, so that's why mean, median, mode are residing with each other. So that's why mean, median, mode will be equal to each other. They will be residing at the point of 0. But here we are seeing again, guys, mode will be at the top, and now the tail is going towards this right direction, right side. So this will be called as the right-sided skew, right? And here obviously towards the tail, who will be going? Mean will be going towards the tail, mode will be residing at the center, residing at the top only, and between the mean and mode, what will be there? Median. So median will be presenting between that, right? Median will be presenting between the mean and mode. So over here, sometimes they are asking us this particular thing which I am highlighting, right? This thing, mean, median and mode, that will be equal in the normal distribution curve or the symmetrical curve, that is fine. But what will happen to the left or right sided skew? Non-normal distribution curve, right? Because that is not normal, right? That's why non-normal. So in those cases, what will be the answer? if you are talking about the left sided skew, guys, if you are talking about the left sided skew, mean will be on the lower side and the mode will be at the top side. So mode will be on the higher side. After that, there will be the median, and after that there will be the mean. So mean will be on the lower side. If you talk about mean, will be on the lower side always in the left sided skew. In the left side there is always mean, which is on the lowest side, and mode is the god. Mode is the god in the left sided skew. Mode is the god, I mean mode will be at the highest place. Mode will be having the highest place. So mode is the god in what thing? Left sided skew, right? And if you talk about the right sided skew, right, now the story changes. Just remember the one, right, that is the left sided skew, and you need to just do the opposite thing. You need to just do the opposite thing, because median place is not changing. Median was in the center as far as negative skew is concerned, that is the left side skew, and in the right side skew also, positive skew also, the median will be in the center only, as you can see over here. Median will always be in the center, but it is about mean or mode. On the lower, mean it should be on the lower side or it should be on the higher side. Mode should be on the lower side or mode should be the higher side. So just remember, on the left side we are having mode is the god. It means that mode will be having the higher position, right? And just opposite to that will be happening, just ulta will be happening in the right sided skew. So that's so simple. So over here we can see the mean will be having the higher position. Now here in this case mean is the god. So then mode, then it will be having the lowest value, right? That's how the nature is. So over here in the left sided mode is the god. I think that will help you to remember this. Okay, otherwise you shall have your own methods as well, guys. So that was about the various types of the distribution. I mean non-normal distribution. We shall be having left side skew or the right side skew, and what about the mean median mode arrangement, you should know about that. After that we shall be using the box and whisker plot. Now what about the box and whisker plot, guys? This box and whisker plot, first of all, it is also called as the box plot. That is already the MCQ, guys. It is also called as the box plot. Second question is that what things we are having in this case. We are having the data such as minimum and the maximum range over here. As you can see over here, minimum range and the maximum range, right? In the center, which what you are seeing over here, this is called as box, right? And these are called as whisker, which are the part of it, right? The peripheries which are actually coming out of the box, that is the whisker. So this is the whisker, this is the box, two parts over here in the box and whisker. That's why we are calling simply it as box and whisker. In the center we are having the box. It's not important that it should be in the center only. It could be present on the peripheries as well, but usually there is a box, and attachment to it on the both the side, they are called as the whisker usually, right? Now inside the box, what we are having? Inside the box we are having one division, and the division is the intercept usually. Guys, this division which I am talking about, this division is usually the intercept. This division is called as the intercept, and this intercept is dividing the box into two parts. Now there could be so many of intercept, right? There could be 2 intercept, 3 intercept, 4 intercept. So that's how they will be dividing the box accordingly. So here I can see 1 intercept, and that 1 intercept will be considered as the median. 1 intercept will be considered as the median over here, right? Usually I am saying median is telling the center of the box, right? Median is telling the center of the box. I told you in some class that when I was talking about the I was talking about the mean, median and mode. In that class I told you where I was talking about the measures of center tendency. There I told you that median is the 50th centile. I told you that median is the 50th centile. Basically it is telling us about the center. What is the median, right? Arrange the numbers in ascending or descending order, and then whatever the mid value you are finding in that particular data, that will be called as the median, right? That is the definition of the median also. So here median will be actually telling us the center of the box. Then at the corners of the box we shall be seeing something. At the corner of the box we are seeing that Q1, and on the other corner we are seeing the Q3. Q means the quartile. Q means the quartile, Q1 means lower quartile, Q3 means higher quartile. Why we are calling them as Q1, Q2, Q3, right? Because this will be the Q1, at the median there will be the Q2, and at the last there will be the Q3. It depends on the how many intercept are there. If the 4 intercept are there, for example, right, then they will be dividing that. For example, 2 intercept are there, then 4 quarters will be there. 3 intercept are there, then in that case 5 quarters will be there. So this is the thing over here, that's the story that will be going on, right? So Q1, if the intercept is there, that will make up the median, Q2 and the Q3. So it will be dividing the box into how many parts? 2 parts, and those 2 parts will be called as quarters. These 2 parts will be called as quarters. This is 1 quarter and this is another quarter, right? In the box and whisker, whisker is containing the 25% of the data. Whisker is containing 25% of data. Here also whisker is containing 25%, and this is also 25%. Rest of the 50% will be going where? To the box only. Inside the box, one side will be having the 25%, other side will also will be having the 25%. So how many things I have told you in the box and whisker chart? There is a box, there is a whisker. Right? Whiskers are the attachment to the box. Box is containing 50% of the data. Doesn't matter the box is small or box is big. Doesn't matter. Box will be containing the 50%. If it is divided, half of the box will be containing 25%, half of the box will be containing 25%. Whisker will also be containing this whisker will contain 25%, this whisker will also contain the 25%. Clear? Right? Then I talked about the quarters. The median over there, the intercept will be dividing the box into two parts. It depends on how many intercepts are there in the box. In one intercept, center one, it will be determining the median, and median is the 50th centile. That will be telling the center of the box. Second thing over here is that the corner of the box will be telling us about the quartile. So if the one intercept is only there, so two quarters are there, it means one corner, then the center one and the third one. So Q1, Q2, Q3, lowest quartile, highest quartile. Okay, like that we can actually determine. Okay, so this is the story of the box and whisker plot. According to the box and whisker plot, we can merge the non-normal distribution curve with that. How we can do that? Let's find it out. So here guys, for example, we are seeing that normal distribution curve. In the normal distribution curve, how was the normal distribution curve? This was the normal distribution curve where the tails of the normal distribution curve never touch the baseline, right? That I told you in the normal distribution curve class only. And the mean median mode will be residing at the center, which is the 0 over there, right? So here what I can see, this would be the whisker. I am writing with W. This is the box in the center, and again this is the whisker. Whisker will be containing 25% this side, 25% this side. In the center box is there. There will be the 50%. The total it will be becoming 100%. So here what I can see that box is just in the center. If the box is just in the center, doesn't matter the size of the box. Doesn't matter the size of the box. Size could be bigger, size could be smaller. Doesn't matter. But if it is relying on the center and the whisker is actually symmetrical to that, right? One condition could be this whisker could be small, this whisker can be large. This whisker could be small, this whisker can be large. So that is not the case. Here the whiskers are equal in size and the box is in the center. Doesn't matter the size of the box. That will be called as a normal distribution. So here I can co-merge my normal distribution curve like this. Are you understanding? So this is my normal distribution curve. However, right, so here what I can see, Q1, Q2 and Q3. 3 quartiles over here, isn't it? So that is the thing over here, right? Okay, this should be the quarters, right? And in the center there will be the median. Okay, no need to repeat everything. Okay, so we know that already. What about the positive skew, guys? What about the positive skew and the negative skew? Positive skew means the tail will be going toward the right side. In the negative skew, tail will be going toward the left side. So here in the positive skew, I can see that here the tail, how it is going, this part of the box is smaller and this part of the box is larger, right? Here the median is actually shifting towards that side. So here the tail will be presenting on that side. So here if I am drawing this distribution curve, so it will be non-normal distribution curve. As you can see over here, this will be non-normal distribution curve, right? It is going in some other direction. So yeah, so this is that non-normal distribution curve, isn't it? So this will be the right-sided skew, right-sided skew. If you talk about the negative skew, as you can see over here, right, now this curve will be like this, isn't it? So this is the left-sided skew, right? So that's how you can merge the box whisker plot with the non-normal distribution curve or the normal distribution curve. I hope you understood that very well. Revise this and I will see you in the next one. Thank you.